Good afternoon to everyone. I hope I am audible clearly.
Yes, madam, I hear you.
Thank you, sir. See, I am delighted to welcome you all to this special session on machine learning techniques, industry expectations. We is we honored to have us today a distinguished guest and expert in the field, Mr. Karthik Ganesh.
Madam,
Yes, sir.
madam, someone is
Yeah,
talking.
tell me, God, tell me. Sorry. Am I audible?
You are audible to me,
Okay, sir.
but I'm not sure why some student called you.
Yeah. Anything else? Anybody want to share anything? Someone called, it seems. Robot, am I audible to you all?
Yes, ma'am.
Okay. Okay, sir, we can continue. So, we honored to have with us today a distinguished guest and expert in the field, Mr. Karthik Ganesh Durai. Sir, thank you very much for your acceptance in your busy schedule, sir. Mr. Durai is founder and CEO of Quantum G Research Labs Private Limited, a company at the forefront of research and innovation in quantum computing and machine learning. He is also the co-founder of Quantum Computing India. In addition to his entrepreneurial endeavors, he served as a professor of practice at NMIT Bengaluru as well as VIT, SRM University Chennai. So please, all of you, please join with me in welcoming our eminent resource person, Mr. Karthik Ganesh Durai, to deliver his talk on machine learning techniques, expectations of industry. Welcome, sir. Welcome. I am welcoming Sujita ma'am, who is co-teacher of this subject. So I welcome you all once again. Sir, I hand over the session to you now. Thank you,
Thanks,
sir.
madam. Thanks a lot. It's a great honor to present students and then faculties from Karanya University. It is an amazing experience. And today's session is not PPT driven session. When we discussed with the madam, I shared my interest to make something substantial where student to use immediately. That is the reason why we decided to go with your syllabus. So today's session is a kind of walk through your syllabus. Why the syllabus is designed this much, or what are the contents, why it is designed, and what industry is expecting from these concepts. So the mapping or the connection between the industry expectation then academic excellence is not clearly defined for students. That is one reason why students are not interested in the subject. Hope you can connect with you because I also a student, right? Like you, some time back, long time back. So I know the pain. Why do we need this subject? Oh my God, what is the use? And particularly, you might feel that when you are reading this data structure and algorithm. Am I right? Many, why do we need this data
Yes.
structure? I don't know whether you have studied data structure and algorithm, but I studied data structure and algorithm, and then I taught data structure and algorithm. I struggled a lot to create interest on the subject. Something similar to this one, this machine learning techniques. Because when you learn machine learning, most of your well-wisher or industry experts or your lecturers, faculty members used to stress the importance of mathematics, but most of us don't like, or why do we need mathematics? We are software engineers, why can't we write the code, right? That's what running in your mind. So considering all those things, I thought of explaining these topics, why these topics are essential, where industry is using these topics, and how can you build something useful by learning these topics. That is what today discussions. Feel free to stop me at any point of time because this discussion is exclusively for students. So whatever you need, I will share. Now you may have a question. How can you share? What do you? So obviously you should know about me. Then only you can ask the question. So I have prepared a simple mind map about me. I started my career in 1992. So 1992, as part of my undergraduation, I did a project on natural language processing. So the artificial intelligence I worked on 1992 itself. But obviously, artificial intelligence is not the job market there. So I started working on COBOL language. Then I learned Fox Pro. I built multiple commercial solutions for invoice raising, purchasing, sales, organization, expenses. Those periods, Tally software was not popular. So I built most of the accounting financial systems for my factory when I was working in a factory based out of the headquarters is in Gudiyatham in Tamil Nadu, but I worked in a place called Karaikal because that is my native place. So that is where I learned all those EDP things. I was an EDP in charge at the time. Then I moved to entrepreneurship. That time itself, 1992, I started building commercial solutions for other organizations. So during that period, I worked on Visual Basic. And for a short period of time, I was a government servant in Pondicherry government, but I don't like the job, resigned the job, went to Singapore, started working on Oracle that time. Then Oracle and moved to business intelligence. That is where I came to know that there is a language called R. That R language is used for statistical modeling. That so I started learning R language in 2007, but I did not use that because that time um, my organization had a strong R team member, so they built the solutions. I just did the visualization using a tool called ClickView. It was popular business intelligence like Power BI, Tableau. Now, like that, it was popular in those periods. Then I moved to data analytics. I returned to India, joined Dell Bangalore as a data scientist. So that time I started working on Python language. I started building solution end to end, meaning that data engineering, model building, data visualizations on various domains, supply chain management, operations, customer support, and um, server analytics. Server analytics is something more technical oriented things. And I handled petabytes of data. I worked on Teradata, big data, SQL Server, data lake, data warehouse, whatever name it, data mart, whatever you name it. I almost worked in all environment during this 12 years period as a data scientist. But I love quantum, so I resigned my data science, classical data science job in 2022 and moved to full-time quantum machine learning expert. So now I am working as a quantum machine learning consultant, supporting many organizations internationally, helping them to build their quantum solutions. So short introduction about me. So I have started with the prologue, but now I work in quantum machine learning. I know almost all the languages except Java. I purposefully did not learn Java, but starting from those old language, the latest language like Julia, Rust, those languages also I used to work because my job needs that skill. Because my juniors used to come to me, ask questions. That is the background. Hope now you understood. Whatever question you ask, mostly I will be able to share from my experience. Okay, with this one I encourage all of you, post questions. I will keep checking this chat window, so make use of this opportunity. Ask lot of questions. If you are not comfortable in English, feel free to ask me in Tamil or Telugu or Kannada. I speak most of the South Indian, all South Indian languages, you can understand that way, and Hindi also. So being in Bangalore, we have to be multilingual, so I can answer questions in your native language also. Make use of the time. Let us jump into the topic. Okay, all good? Ready for the discussion? Amazing. First thing, the module one, they are discussing introduction concept learning and types of machine learning. So why they are telling types of machine learning? Okay, before that, I will always recommend people to ask this question. Always ask this question: why, what, how? Why, what, how? That is the question sequence. But usually, what we learn or what we ask how to do. For example, someone tells build a classification program. We are not asking why do you need. We are asking how to do. That is what a typical engineer mindset, a solution provider mindset. Okay, you need classification model. Okay, how to do that? But you should ask this question: why do you need that classification model? Because if you understand why, you can plan your strategy. Without planning a strategy, if directly jump into the coding, after spending 4 hours or 4 days, when you show your program to your client, they will tell, no, 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 I don't want this one, I want something different. Because you missed an important question: why? Always ask this question: why, what, then how. You should get clarity in these two questions: why and what. Unless you get clarity on why and what, whatever doing in how, that will not be used by your end user. You got the point? You can use advanced languages, doesn't matter. If the end user is not going to use, no use, whatever efforts. And very important thing what you have to learn, the machine learning or any data science is used for grouping. The grouping can be regression, classification, clustering. Again, why do we need to group? Or why do we need to classify? Or why do we need to cluster? So these questions are useful for decision making. See, the industry is using machine learning for decision making. That's it. If the person who is going to make decision, not the people who are doing day-to-day operation, right? The decision is made by executives. That is one reason the machine learning or AI ML solutions are having high visibility to your executives: chief marketing officer, chief financial officer, chief executive officer, chief data officer, chief operating officers. Those chief people, executives, they have to make decision. For making a decision, they can do with the intuition or with data driven. Intuition or data driven. Earlier or before the machine learning or AI become viable, most of the management people made decision using their intuition. They know very well, if we start this operation, it will give this much profit, or this will give this much effectiveness, efficiency. So based on their intuition, they will make decision. That is where most of the things are failing, because intuitions are biased. People have their intuition based on their past experience, then their exposure of current technology, and they have some, if they are stereotypes, they will make wrong decision. That is why industry is preferring data driven. You might have heard the word, we believe in God, we believe in God, everything else is data. I don't know how many of you know this one. This is a popular saying in the corporate world. We believe in God, everything else is data, meaning that next to God we believe data. That is when the data is accumulated, the industry is able to build machine learning solutions. And that is because of the decision making thing. There is a concept called data decision science. Decision science. Decision science is supported by data science. Data science is supported by artificial intelligence. Artificial intelligence is supported by machine learning. Machine learning is supported by deep learning. We understand the flow. This is the actual flow. The machine learning is a tool for AI. AI is tool for data science. Data science is tool for decision science. For decision science, not only data science, software engineering also a tool. Before the data science, The decision were made using software engineering. Now you will get the confusion. Oh, this guy is telling something different. We think that software engineering for development, solution development. Yes, we are building software for what purpose? If you ask the why question, you can understand. Softwares are built to make the operation easy. After the operation, that operation input or the outcome of operations informed to executives, they are making decision again. If you see everything else is for making decision. So now if you understood this decision science is an important thing, obviously your question will be who who are the end user, or whether it is chief marketing officer or chief financial officer or chief operating officer. So based on their executive, you have to present your data in a different visualization. Same data, marketing officer will see differently, financial officer will see differently, operation officer will see different. Now you understood why a simple model is executed or implemented in a different way. It is because the end user. Hope I made an important aspect which is new to you. With this as an introduction, let me come back to your subject. So here, now we understood it is decision science. So there are multiple things. ML is one of the technique. In machine learning, there are many approaches, tools, and techniques. That's what we are going to see now. So after that, for that, you have to understand what are the types of machine learning. So if you think types of machine learning, obviously you will come to know supervised learning, unsupervised learning, reinforced learning, hybrid learning. There are 3 or 4 types of machine learning. Each type of machine learning depends on your input data and approaches. So there are supervised, unsupervised, and reinforced, or deep learning. So hybrid like this, there are methods or types of machine learning depending on your available data availability. Then what are the examples problems? You should understand where are we using machine learning problems. That is where the examples are coming. I'm not going to explain that one. Models and data. So this is an important concept. Models and data. Models and data. When we see the model, obviously, maybe for our world it is Aishwarya Rai. When it comes the word model, I'm not referring the cinema or models in the advertisement. I'm referring to mathematical models. So mathematical or statistical models are very important. Statistical model. I'm referring to mathematical and statistical model. So why we need mathematical model and statistical model? These models have certain characteristics like accuracy, technology, and time complexity, and underlying mathematical object. Like that, there are many characteristics. So you have to go through those characteristics of this machine learning model. Then only you will be able to choose the right model. See, selecting the right model is very, very important. But a clean data is more important than anything else. There is a saying, garbage in, garbage out. Obviously, everyone knows that if your data is garbage or if your data is not accurate, your model output is also going to be inaccurate. So that is the one reason why data is given equivalent important to model. It's not just a model. The data is also very important. And that is where you are learning the characteristics. Then concept learning, theory of generalization. See, the theory of generalization comes from uh, this one. See, the decision science, I told data science and software engineering, right? The software engineering always specialization. Anyone have any question here? When I say software engineering always specialization, for example, you are building, imagine that you are building one software for a mobile app or web application for inventory control. So that is meant for only inventory control, only for specific organization. That is what most of the software engineering outcome or output are generalized. So if you want to change that, you have to change your program, because inside the program you are using a rule based engine, whereas data science is using data driven engine. See, this is very important point. When you are building something with the data driven, that will be a generalized solution. But if you are using something software engineering, that will be rule based engine. Rule based engine means you will use if statement for every condition or every rule. You will write a if statement. If anything new comes, your software solution cannot handle. Whereas a machine learning model, being a data driven, it can handle a new rule also. It is because it is based on data. You got the point? Any question here? I will give some few time, sir, few minutes for you to ask questions. No questions? Very good. Let me check, is there any question in the chat window? Students, feel free to ask questions, because this is one of the opportunity. You can ask questions. I can share from my experience. Okay, cool. And if you are shy, you are not able to ask now, please connect with madam. Madam will help the question answered from my side. Okay, because I'm happy to support students.
Sure, sir.
Great. Now let us move on to the second unit, module 2, feature engineering. So module 2 has feature engineering, data collection, pre-processing. Let me focus on pre-processing. Just now I told garbage in, garbage out. So the data are generated by operations team. Operations team means the people who are working in the industry, managers, supervisors, workshop, workman, labor, and clerk. All these people are generating lot of data using their software. These data are suitable for the operations team, meaning that for their day-to-day operations. But this data cannot be summarized by executives, and that need to be processed. That is where the pre-processing come into picture. We will do the data cleaning and the data transformation. So in the data transformation, it is very important to make this data suitable for processing. Why can't we process all the data operations team generates? Imagine that there is a banking software. That banking software is generating IP address, date, time, the account ID, then customer ID, customer location, customer name, and the mode of withdrawal, amount withdrawn. All those things it is generating, right? It has different types of data: numerical data, date information, characters, what is called categorical data. Like that, there are different types of data. But mathematical model and statistical model are good with the numbers. See, now you understood why we are learning these models. See, why we are learning mathematical model and statistical model? Because the data need to be transformed suitable for those models. So how we can do that one? There are many ways, like normalization, binning, binning, discretization. Okay, so what is normalization? It is very interesting, very useful concept. I will explain you. If you take one banking application, imagine that I am analyzing the ATM withdrawal happening in Coimbatore. Throughout Coimbatore, there may be 1800 to 2200 ATM machines, and the money withdrawn from ATM machines will range between 100 rupees to 10,000 rupees, right? 100 to 10,000. If you see 100 two number, 3 digits, 10,000 5 digits. And if I perform some operation with 110,000, my mathematical model can process. But imagine that I'm handling the bank withdrawal or check transaction. Check transaction can be 100 rupees to million or crores. Now, if you see this, they are very big number, right? 100 only 3 digits, crores 8 digits. So when the range is very large, if you think about the programming aspect, whether you will use integer or big integer. See, integer, we can use it for 5 digit number. For 8 digit number or 9 digit number, we have to use big integer. So your program need to get accommodated for the big integer as well as small integer. Obviously, this variation in your data causes a more inefficient data representation. So usually in machine learning, what we will do, any number of data will be normalized to 0 to 1. Now you can ask how it is possible to convert 100 to 1 crore into 0 to 1. It is possible. Min minus max minus min multiplied by the number divided by max will give you the normalization. So everything will be converted into 0 to 1. If we convert everything into 0 to 1, we use only one double floating point number that can handle all data. So normalization will improve the performance of your model by bringing your data within the predefined model. That is one example. Like that, there are many advantages. There is normalization, there is encoding. Categorical data, string data cannot be processed by mathematical model because mathematics can handle only number. So these numbers, these characters, for example, male or female, that should be converted to 0 or 1. Or the location of the ATM machine, maybe Gandhinagar, Gandhipuram or Ganapati or Nava India or any other places in Coimbatore, right? A place where your college is there. So those locations are character. Those character need to be encoded into numbers. These are all falls under normalization, encoding, all those things are comes under data transformation. Then binning is the range, how many range, like a distribution, distribution histogram. Then discretization, converting them into a continuous values will be converted into discretization values. These are all will help the mathematical model to work efficiently. So now you understood data transformation is important step for improving the performance. There is one more important thing called dimensionality reduction. Dimensionality reduction. Actually, there is a saying called curse of dimension. You search for this one. Curse of dimension is a big problem in machine learning. Now you will consider what is dimension. Correct? We know 3 dimension, 2 dimension, x and y, 3 dimension, x and y, z, 4th dimension, time, right? I'm not referring those dimensions. If you take a student record, student registration number, student name, date of birth, date of joining, department. This tuple or this record has 5 dimensions. That is how you have to understand from the machine learning perspective. In machine learning, dimension means the columns. It is a it is a very important understanding you should have. So the number of columns will cause the calculations to go exponential. Why it is called? It is it the computation becomes exponential, or the computational complexity is exponential. That is the curse of dimension. So when you have the larger dimension data, for example, imagine that I have a data set of 100 columns with 1 million rows. I have to build a matrix of 1 million by 100 columns. So this matrix will be manipulated by many other machine learning models. So row I cannot delete, I cannot reduce because that is actual transaction. But the columns I can reduce. If I reduce the column, it will give a much better performance. That is the reason why the industry is trying to identify the important column of your data. That important column is called feature. Important columns in your data. So your data have many columns or many dimensions, 100 dimensions. Out of 100, you can use only 60 or 65 columns to perform classification or regression or clustering. Those columns are called features. A feature engineering is an important activity. A feature engineering is a exponential problem. Feature engineering, it is also called principal component analysis, in short PCA. PCA is an exponential problem. So when I say exponential problem, it is comes from data structures and algorithm. You may see O n, O log n, O n square, O 2 power n, O n factorial. That complexity I am referring. So PCA is an exponential problem, meaning that O of 2 power n. If there are, imagine this way, as I told you, a data set 1 million row with 100 columns. If you are trying to build a PCA or if you are trying to find the features, it may run for 1 hour. If you add one more column, 100 column, if you add one more column, 101, the same model will run for 2 hours. If you add one more column, it will run for 4 hours. If you add one more column, it will run for 8 hours. That is the problem with the feature engineering. Feature engineering is a exponential problem, O 2 power n. That is the reason why we are getting this curse of dimension. Make sense? It is interesting to see this, right? Any question? Any question, students? My dear friends, ask questions. I will give 1 or 2 minutes. Any student have any questions? Sorry, I should have closed that window. Close this window. No questions? Okay, right. I know post lunch discussing a technical discussion, it is not so easy for students. Of course, it is easy for me because I'm just speaking. For you, it is not so easy. I understand your challenge. No problem. Now let us focus on module 3. So module 3 is the linear, non-linear and probabilistic model. So if you see the module 1, we have come across the models, right? Mathematical model, statistical model. See, in your theory, you will learn a lot of things because if you see the books referred by for the syllabus, it is Plash, it is Art of Science of Algorithms, right? Then there is one more important book, the Sebastian Rashka, Wahid Mizrali. Their book is also very interesting book, full of technical. But you see the other book by Trevor, that is elements of statistical learning. That is full of statistics and mathematics. So these are all very interesting to understand how mathematics and statistics are contributing to your machine learning. One thing I'm telling you, without mathematics, if you are learning machine learning, you might have seen a lot of YouTube, what is called mind map, sorry, minis on mathematics for machine learning. There are many things. I want to show one particular image where there is a weapon. You can check this one. See, machine learning is nothing but algorithms and mathematics. And you see here, this image, it is pure mathematics. So machine learning is, you see here, statistics put with the machine learning, we will get artificial intelligence. And this is common: vampire, sunlight, Superman, kryptonite, deep learning practitioner, mathematics. But if you don't understand mathematics, it will be very difficult. Let's understand machine learning, then you will hit by mathematics. So why I'm telling these things, there is many reasons to understand. Let us focus on the subject. Okay, any question, anyone asking question? Let me check the question. No question. Okay, right. Yes, I saw someone unmuted. Okay, the module 3, you are discussing with various linear, non-linear models. So the word linear, many people, um, so if you are coming from a strong mathematical background, you can understand linears are a straight lines, non-linear are parabola or non-straight line, right? Anything which is not straight line, they will become non-linear because it can be a circle or parabola or hyperbola, whatever it is. So why we need a linear system or non-linear system? There is a beautiful reason why we have to do that one. And if you recall the formula y equal to mx plus c in your school days, y equal to mx plus c, y equal to mx plus c examples. Okay, I'm just opening that one. You remember this kind of chart, y equal to mx plus c, and that chart will be used to predict or find the missing value or forecast the future values. Do you recall that one? So a simple y equal to mx plus c can be used for prediction. or forecasting. So y equal to mx plus c is not just a line drawing algorithm. It is a machine learning foundation or machine learning fundamental concept. So any machine learning professional must understand y equal to mx plus c. How y equal to mx plus c is used to forecast or predict or find the missing value. That is the foundation. And y equal to mx plus c, we have only one x, meaning that you can analyze only one variable. That is where we are going to regression in statistics. Regression formula. If you see the regression formula, it will have y equal to beta 1x, beta x2, beta 2x, beta 3x, like this. It can handle many number of x's. So if you are having a data set of 100 columns, each column is x1, x2, x3. So if you have only one column, you can use y equal to mx plus c. If you are having multiple columns, you can use regression. That is the connection between mathematics and statistics. But these things may not give accuracy. That is when we will move to matrix. When we put the matrix that can behave as a neuron, that is where artificial neural network came into picture. Now you see the story, right? Y equal to mx plus c, regression, matrix, neural network. And this neural network have formula. They are all matrix related formula. If you see the formula, they are a sigma, meaning that they are added with weight and bias. They are able to rebuild a matrix. That matrix is used to find out the final value. This is a beautiful concept. See, if you try to understand mathematically these concepts, you will really fall in love with machine learning. How beautifully a software driven solution, you see here a special purpose application like you connect these points. For decision science, we have data science and software engineering. Software engineering rule based engine, but data science is data driven. How it is data driven? Because of neural network. What is neural network? It is a matrix, a beautiful connection. If you understand matrix, linear algebra, that's it. You are good at mathematics. You're good. You will start loving machine learning. It is not a big deal. Concepts. Y equal to mx plus c. I let you read the words. Line drawing, linear regression. Then your neural network using matrix. Then there are two more concepts: conditional probability, Bayes theorem. That's it. If you see the conditional probability will result in conditional probability that will result in this formula. This will result in decision tree. The decision tree, multiple decision tree, random forest. Random forest can be used for classification. That's it. These are the 5 concepts are enough. Foundationally, any machine learning will fall under any one of these 5 models. Okay, so this is the foundational concept for mathematics. That's why I'm telling it is not very difficult to learn mathematics for quantum computing, because these are only 5 concepts, right? And coming back to our module 3, we have another 9 minutes. I don't think within 9 minutes I can explain all the concepts, but I don't want to rush also. Hope you understood, because
Sir, excuse me, sir.
Madam,
Sir, if you don't mind, we can have another session also based on your availability. So really the sessions are nice and going very much insightful, sir. Is it comfortable to you to continue during some other session, sir?
yes, madam. I can spare online. I can spare, madam. No problem.
Okay, sir.
You
Maybe
discuss with the
next
students and
Thursday.
other department.
Okay, sir. Maybe during next Thursday, if I will check with my co-faculty, and then if you're based on your availability, we can fix for the too, sir.
Sure, madam.
Because you are giving yes, sir,
Yes,
sorry.
madam.
Because you are giving detailed insights about each and every model. We feel that it is very much useful. And as you said, if you are rushing up, then it may be not that much satisfied one. As whatever you covered so far was very much useful and also very detailed one in terms of industry perspective, sir. So that's why
Yes.
I'm asking. Okay, sir.
Thanks, madam.
Okay.
Thanks, madam. I'm ready to share that, madam, because that will serve the purpose because this is very important subject. I don't want
Yes,
to rush and then make that I have completed. No, that won't helpful.
yes, sir.
That's
So,
great. I will share this mind map later with you, madam, as an image.
okay, sir.
Um, because PPT is not, I don't like PPT. I will use either Blackboard or this kind of tools only. Later, I will share that one. Any question, we can answer question for another 7 minutes. Students or staff, please feel free to ask questions.
Students, is
Okay,
there any
now,
questions?
if no question, I can explain my first machine learning problem.
Okay,
My
okay, sir.
first machine learning problem I built, not even at the time, I don't know that is a machine learning problem. That time, I think it is 2008. I have to build one solution for supply chain management. At the time, I was working in Singapore for one of the largest agro product supplier. They supply high quality cashew nut, sugarcane, and teak wood. These kind of agro product for number one Fortune 500 companies. So they, for example, say we will buy sugar for how much? We will buy sugar, right? But they will buy sugar for million dollar, billion dollar contract from South Africa and India. So they will, whenever they buy a lot, maybe we $500 million lot, they will safeguard that contract into commodity market. The corresponding purchase, there will be a virtual purchase in the commodity market. Now the commodity market also will give you profit or it will give you loss. Real market also you will give profit or loss. So they have to analyze whether my purchase again in Nigeria on August 2024 is running profit or loss. If it is loss, I have to hedge it by purchasing another contract in the commodity market. So this kind of transaction need to be connected with multiple systems. Our purchasing system and current market rate and the commodity market. That commodity market is coming from a service called Bloomberg. Bloomberg through satellite, they will send the up-to-date data every 5 minutes. So I have to combine these three informations and make a decision whether my position is profitable or not. And for your surprise, I built the whole system using Excel. I did not use Python because Excel has a concept called VBA, Excel macros. I connected with the Oracle PLSQL and ClickView libraries, Bloomberg library, all this library I connected with the Excel. I built the proof of concept, handed over to my software engineering team. They built as a separate solution using C language. My work as a data scientist to give them proof of concept. Hey, this is the approach, this is the formula, this is the data processing, this is the mathematical model, this is the statistical model. I want output this way. For this one, most of the data scientists, they will start with the Excel, not with the Python or not with any other advanced language. We always start with the Excel to build a small solution, proof of concept, go and show to our executives, get their approval, then we will form a team, then ask the team to start working on R language or Python language. Once they build, we hand over this to web development team. So this is what we are doing in the industry. So if you are thinking that I'm a data scientist, I don't need Excel, please change your mind. If anything I want to say now, one takeaway, start learning Excel for the next 3 weeks. Without Excel, don't think about machine learning career. Yeah, that's what I want to share. I'm stopping here, ready to answer your question.
Sir, thank you, sir. Thank you very much for your insight, sir.
Thanks, madam.
Based on availability, we can have another session too,
Sure,
sir.
madam. Sure,
Okay,
madam.
sir. Shall we wind up, sir?
Thanks, madam.
Thank you, sir.
Thank you.
Thank you so
Bye-bye.
much. Thank you all for joining. And I hope this session would be very much useful to you for your further journey in terms of your machine learning techniques, theory, as well as our industry-oriented preparation. Thank you all.
Thank you.